Okay, Bismillahirrahmanirrahim. Let's start. So what do we have in this problem? We have a velocity time graph. So the particle is starting from the origin and moving in a straight line in one-dimensional motion. And I give you the velocity time graph. So the question is, at what time is the particle going to change direction? Explain why. Yes, Abdullah, Bismillah.
The first thing is from 0 to 5 seconds. The acceleration is high.
Okay.
Velocity. Sorry. Okay. And from 20 to 30, he is going down.
The velocity.
Yes, the velocity.
Yes. The velocity is decreasing.
Yes.
Correct. But now, at which time is my particle going to change direction? Can you give me a specific time at which the particle will change direction?
25.
25. Okay, good. So why? Look here, I give you a velocity time graph. As you can see, what I said in class is when velocity is positive, I'm moving in the positive direction. When velocity is negative, I start moving in the negative direction. When velocity is 0, I stop. So here what's happening, as I think Osama or Abdullah said, here I'm speeding up, right? Okay, and then I have constant velocity, but I'm still moving in the positive direction. Okay. Then what's happening? From 20, I start slowing down, but I'm still moving in the positive direction. Okay, because the velocity is positive all over here, between 0 here to 25, the velocity is positive. I'm still moving in the positive direction because the sign of velocity is giving me the direction of motion. So again, I start from rest. I was, let's say, at rest. The velocity is 0. I speed up, moving in the positive direction. Then constant velocity. Basically, I put my cruise control. Velocity is maintained constant. Then from 20, okay, somebody is writing on the board. So from 20, I'm still moving in the positive direction, but the velocity is negative. The acceleration is negative. I'm slowing down actually. And I slow down. At 25, exactly, I stop. And then the velocity becomes negative. So now that means I'm moving in the negative direction. Okay? So this is what I explained here. The velocity change direction at t equal 25 seconds. Before 25, I'm moving in the positive direction. But moving in the positive direction with different regime. I'm speeding up, constant velocity, slowing down, still moving in the positive direction, then I stop. After 25, velocity is negative, meaning I'm moving in the negative direction. Okay? Second question, what is the average acceleration of the particle between 20 and 30 seconds? So what's the definition of average acceleration? You look at your formula sheet, right? So average acceleration is a change in velocity divided by change in time. Okay. So write down this, it's in your formula sheet. Average acceleration is V final minus V initial divided by delta t. Now here, what did I say here? I want it between 20 seconds and 30 seconds. V final is V at 30 seconds minus V at 20 seconds divided by 30 minus 20. So V at 30 seconds, I read it here and I see that it's minus 5 minus, now V at 20 seconds, I see it here, it's 10 divided by 10. And you get an average acceleration of minus 1.5 meter per second squared. And you see it here, okay? In this phase here, here, for instance, velocity is positive, but acceleration is negative. So I'm slowing down. That's why I stop eventually. Now, when I stop now, velocity is negative, but acceleration is still negative. So I'm going forward, forward, forward. I stop. And then I start speeding up, but in the negative direction. Okay, so here I'm speeding up. Good. Now let me go to this problem, which is essentially the same. I just changed the x-axis here, and you know how I give exams. Okay, I will take the recitation problems and I will change the numbers. Good. Sometimes, from time to time, I will invent new problems. So here I have the same graph, velocity time graph, but you see here, of course, I changed here. Okay, so this is 20, this is 25 here, and this I said this is 23. Okay, so this arbitrary unit does not respect the scale, but anyway. So now here the question is, what is the displacement of the particle between 5 seconds and 25 seconds? So 5 seconds is here, 25 seconds is here. I have a velocity time graph, but now I need a displacement. So you know that velocity is derivative of position with respect to time. That means that dx is v dt. Now, if I take an integral, I will have between t initial and t final. Between t initial and t final, you don't need to know how to get an integral, but here, of course, you will get x final minus x initial, which is delta x, this is displacement, is equal to integral between t initial and t final of v dt. And this, what I said in class, this is an area under the curve of the velocity time graph between t initial and t final and the time axis. So this is area under the curve. But which curve? VT graph. Between t initial here, and t initial is 5, and t final is what? 25, right? So I need the area between this and this. So I need this area here. So I need the area of this rectangle and the area of this triangle here. And both of them are positive. And then the area of this triangle here, which is negative. Okay. Displacement is an area under the curve of a velocity time graph, just because of the integral. So this is what I did here. Okay, displacement is area under the curve, as you see. So what is this area here? Well, you know how to get the area of a rectangle. So 15 multiplied by 10, and then the area of this triangle here, half basis multiplied by the height. And here's this triangle, be careful, it's negative. And you do everything and you see that it's 160 meters. And this is equal to what? This in reality is equal to x at 30 minus x at 25, because I said 25, x final is equal to 25, minus x at 5 seconds. Okay, so that x at 25 is just 160 plus x at 5 seconds. Okay, so now if in a problem I give you x at 5 seconds, I will ask you what is x at 25. Now, the second question is also straightforward. I already talked about it, average acceleration, so I will skip it. Okay. Good. Now, in a problem, for instance, I will give you sometimes analytical expression. I will give you a particle that is moving along the x direction according to an equation, x of t, x as a function of t. And here I give you what? 50t squared minus 10t cubed, where, of course, x is in meter, t in seconds. So I can ask you, what is the dimension of x, for instance? What is the dimension of 10? Meaning, what is the unit of 50? Okay. So what is the unit of 50? Okay. Of course, it will be meter divided by second square. So this 50 is an acceleration. Well, that's another stuff. Now the question is, first calculate the average velocity of the particle between t equals 0 and t equal 3 seconds. You know what average velocity is, right? Average velocity is displacement divided by time. So it will be x final, basically x at 3 seconds minus x at 0 second divided by 3 minus 0. So let's do that. Now, x at 3, you just substitute and you solve for t equal 3. And you get this. X at 0, well, it's equal to 0. So 0 square, 0 cube, and then you divide by 3, and it gives you this. This is the average velocity. Second question, calculate the acceleration of the particle at t equal 2 seconds. I'm asking you acceleration at a certain time, so I need instantaneous acceleration. So first, I take the first derivative, I get the velocity as a function of time, and I derive again, and I get the acceleration as a function of time. So you know, it's a polynomial function. You derive this, of course, you get 100t minus 30t squared. You derive this again, well, you get 100, you get 2 multiplied by minus 30, and it gives you this. This is my acceleration. And as I told you, I require you to know how to calculate a derivative, right? Integral, no need. If you know it, good for you. But I will not ask it in the quiz. But I will ask you, what is an integral graphically? Area under the curve. And now I substitute now at t equal 2 seconds, I substitute, well, and then I get my acceleration, which is minus 20 seconds, minus 20 meters per second square. This is acceleration at t equal to minus 20 meters per second square. Now, the final question is a particle accelerating, decelerating at t equal 2 seconds? Why? Where is our brother Osama? What do you think? Is my particle accelerating or decelerating?
Decelerating.
Excellent. How did you get it?
Because at t equal 2 in the velocity it's positive, and in the acceleration is negative.
That's correct. Perfect. So let's get the velocity at t equal 2 seconds. Okay. You just have this 100 multiplied by 2 minus 30 multiplied by 2 squared. Okay, this gives you 200 minus 120. So it gives you what? Plus 80, if I'm not mistaken. So A2, we already calculated, is minus 20 meters per second square. And as our brother Osama said, V is positive, acceleration is negative. Okay? V positive, I'm moving in the positive direction, but acceleration is negative. I'm slowing down. I'm moving in the positive direction, but something is holding my back. Basically, I'm braking, so I'm decelerating. Okay, good. Now let's go to this problem here. Which one of the velocity time graph shown below describe best the motion of an object with positive increasing acceleration? This is an A+ question, okay? You know it, good for you. You don't know it, well. So read the question carefully. Here I give you a velocity time graph, V, as a function of time. And I ask you, I give you A, B, C, D, E. Now the question is, which of these curves, A, B, C, D, E, describe best the motion of a positive increasing acceleration? So some gentlemen are writing in the chat. So let me check the chat. You can unmute yourself, okay? And just tell me what you think. So look at it this way. As you know, acceleration is derivative of velocity as a function of time. So here, what I said is the acceleration is not only positive, plus, but it's increasing. So the acceleration actually is linear in time. So acceleration will be a constant, positive constant multiplied by t. if I just said positive and constant, well, you know that if the acceleration is constant, a0, you know, we have a constant acceleration motion. So that means that Vt is equal to V naught plus At. So V is linear in time, and you are doing the lab right now. You are studying about linear relations, right? So if this is T, if acceleration is constant, I have a linear. I have a line because this is linear. This is basically Y is equal to AX plus B. Okay. Here my Y is my velocity, my X is a time. Dependent variable, independent variable. Okay. You will do this in the lab. So when acceleration is constant and positive, V will be a straight line. But here I did not say that. I said the acceleration is positive and increasing. So meaning acceleration in the worst case scenario is a linear function. A positive linear function is time. Let's say plus 10t. So if you have acceleration which is plus 10t, the velocity will be at least a quadratic function, t squared, but a positive number. Let's say plus a t, so it will be plus half a t squared. The velocity will be quadratic, but the concavity will be up, so it will be d here. Well, here you need to know integrals, but this was an A+ question, and we gave it a semester in which the students were, you know, but if you know integrals, this is easy. Okay? If you don't know integrals, you just use this analogy. Okay? If acceleration is constant, a0, velocity is linear in time, it will be at plus v naught, and position, which is basically the integral, will be quadratic, x naught plus half a t squared plus v naught t. You see, because the acceleration is constant, the velocity is linear, and then the position is quadratic in time. Okay? But here I said that the acceleration is linear and positive, so that means the velocity is quadratic. So it will be a parabola, and the position will be t cube. Okay? Anyway, let me go to the next problem. Any questions? I feel like I'm more efficient right now than in the previous section. It's not because of, you know, the previous section, but maybe let me discard this. Maybe this approach is better. Okay, I hope that I will be able to solve this quickly because I have more important problems coming. So what do we have here? D, 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 C. Yes. So it's D actually, yes. So most of you got it right. D. Okay. In the previous question. So D is the right answer. This green here. Okay, let's solve this problem. Now, who should I ask to read it for me? Okay, Abdulaziz, I always ask you. Let me ask Abdul Malik. And then Badr. And then Faris, Faisal.
Yes, Abdul Malik.
Bismillah, Abdul Malik.
Toy turn starts moving from point A toward point B along the half circle track shown in figure 1. It's continuous motion through the straight track from point B to reach point C. It then goes back and stops at point B. What is the average velocity of the train in centimeters per second if its average speed is 3 centimeters per second?
Thank you, Abdul Malik. This is very important. When you have a problem, read it carefully because we are in physics. I can change a small word and, well, if you did not read carefully, you will not even notice. In each problem, there is a keyword, okay, or many keywords. So physics is strongly dependent on the context, okay? So here what I did, I leave A. By the way, I opened the attendance. So please mark yourself present, okay? Let me send the link again. And please stay with me, okay? After you mark yourself present. Well, You are a serious student, so I know that you will stay with me, inshallah. So, by the way, the quiz will come out of these questions. I will change the numbers, of course. So the recitation problem that I sent you, the quiz will come out of them. Good. I will change the numbers. Of course, I will change just few words here and there. Good. Now, here what I did here is I started from A. I went through this half circle here. Oops. I arrived at B. I went to C, and I came back to B. Okay. It's a toy train, as you used to have when we were kids, right? Okay. So the question is, what is the average velocity of the train in centimeters per second if I give you the average speed? So now you have to write what is average velocity. We already talked about it. It's displacement divided by delta t. Basically, it will be x final minus x initial divided by the time I took to cover this displacement. So what is x final here? Well, x final is xb because I end up at b. What is x initial? It's xa divided by the time t. So in other words, the average velocity will be, what is xb? Well, it's just this x of b, right? So it will be 8 minus 0 divided by t. This is the average, okay? Average velocity, 8 divided by t. But I need to find this t. Now, how should I find the t? Let me use the data of the problem. They gave me average speed. So average speed, and this is not in your formula sheet. Average velocity, instantaneous velocity, average acceleration is in your formula sheet. Again, print your formula sheet for the next quiz, okay? Print it out. Tomorrow I will discuss how we will have the quiz. Okay? It will not be multiple choice. So what do I have here? What is average speed is total distance divided by delta t. So total distance divided by delta t is t here. What is the total distance covered by the toy train? It's this half circle, AB, but it will cover BC and CB, so 2 times the distance BC. Okay. And this is equal to 3 centimeters per second. So what is AB? AB is half a circle. You know the circumference of a circle is just 2 pi r. Okay, so half of that will be pi r. Let me put it capital R. And here, by the way, what is the r? Is 4 centimeters. Okay, the diameter is 8 centimeters. The radius is half the diameter. So pi r multiplied by 2 times BC. BC is equal to what? 8 divided by t. And this is equal to 3. In other terms, well, let me put everything in numbers. I'll have pi 8 multiplied by 4 centimeters plus 16. This is in centimeters, of course, and then I divide by the time. So the only unknown here will be the time. Okay, so you get the time. It will give you 9.5 seconds. Of course, because centimeters here per second, we'll simplify with this centimeter. So you get the time. Once you get the time, you plug it into the average velocity. So you will get 8 divided by 9.5. And you get 0.84 centimeters per second. And that's your right answer. Okay, it's not difficult, but you need to see these small differences. What's an average speed? What is an average velocity? Is it clear?
This is actually my question. Why
Yes.
did we take the circumference instead of the area of the circle?
Good. We are covering a distance. Okay. A distance. So if you say area, what's the dimension of an area?
L square.
L square. What's the dimension of a distance, a circumference, or half circumference, L. So your toy train here is going just through this half circle. It does not go through the whole area. He does not go. You will study that an area actually is an integral. It's a double integral. So if you take lines and then you stack them, you will get a surface. But here, your toy train is just leaving A, going to B, going through this half circle.
Okay, I get it. Thank you.
So be very careful with that. But it's a good question. Okay? It's a distance. We are covering a distance. We are not covering an area. So that means I will not see you in office.
Doctor.
Yes, hopefully.
Well, I hope to see you. You will have more than this as questions. We can discuss about other interesting physics. Yes, who has a question?
Yes, Doctor. Can you solve the question number 2 on the same slide?
Okay, let me see. Question number 2 on the same slide. Let me do it. This one.
Yes, Doctor.
Okay, good. Yes, I'm expecting this from you guys, okay? If you feel like what I'm solving is easy, you can bring more difficult problems. But everything I sent to you in the recitation slides are very important. Okay, so take them seriously. And by the way, I will take a question from there. I will change the numbers, of course. I will change the axis. I will change this, I will change that. But if you understand, I put you in Mars, in Venus planet, you can solve physics 101 problem. Okay, now, yes, Sofiane, this is your question. Let's look at your question now. So what do we have here? It's the same type of question because I'm using, you know, S average, which is average speed and average velocity. But now graphically. Now, I give you here the variation of position as a function of time for a car moving along one x-axis, so one-dimensional motion. So here, what did I give you? I give you position, time graph. So the question is, find the ratio of average speed over average velocity for a time interval 0 minute to 6 minutes. So 0 minutes is here, 6 minutes is somewhere here. Okay, good. So whenever I give you a graph, either I can ask you area under the curve, either I can ask you a slope, either I can ask you a direct reading of the graph. Now let's look at it. So average speed, as you said, or as we said before, is total distance divided by delta t. Do we agree? So here, what is the total distance? By the way, delta t here is t final 6 minus 0, so 6 minutes. Let me leave it as this, as delta t. Now, what is the total distance? So the total distance here, I start from 0. I go to minus 2, and then I come back to 0. I'm still in one dimension, okay? And then I go to now 4. What is the total distance that I have covered? Absolute value of minus 2, 2 times plus 4. Basically, I'm covering a total distance of 8. Okay, so the total distance here is 8. I go from 0 to minus 2, and then I come back to 0, and then I go to 4. So the total distance is 8. The delta t is delta t. Let me leave it as it is. It's 6 minutes anyway. Now, what is the average velocity? Average velocity by definition in your formula sheet is displacement divided by delta t. So it will be x final minus x initial divided by delta t. What is x final here? It's x at 6 minute minus x initial, x at 0 minute divided by delta t. So x at 6 minutes is here. I read it. Sorry, 6 minutes is here. Okay. And I read it. You can see it. So it will be equal to V average is 4 minus, what is x at 0? 0 divided by delta t. So it's just 4 divided by delta t. Now the ratio S average divided by V average, the delta t will simplify. I just have 8 divided by 4, which is 2. Okay, so be careful. Now I can ask you, what is the instantaneous velocity at this point? What is the instantaneous velocity here? What is the instantaneous velocity here? What is the average velocity, etc., etc. By the way, what is the velocity here? Slope. So you get the slope here, because if I have a position time graph, the velocity is a slope. Okay, it's a derivative. V is dx over dt, right? So graphically, this means this is a slope. So here, of course, you see, this is a positive slope. Here, I am at constant position. You see the slope here is 0. That means I'm at rest. I arrive at 4 and I stop. And I stay there for a minute and then I start going down again. So try to see what is the motion here physically. The motion is this. I'm doing this. I go to -2 and then I stop and then I go back, etc., etc. You can plot. Okay, now what I will ask you to do is this. At home, here I gave you position time graph. Now I want the velocity time graph. Okay. Once you get the velocity time graph, you go at the next step, which is acceleration time graph. So let me stop by that.
Doctor?
Let's ask first Abdullah and then Abdulaziz, please.
Yes, teacher. I have a
Yes.
question.
Please go ahead.
In the question, he says average speed divided by average velocity.
Yes.
The average speed, you didn't tell us the time, and the same for average velocity.
Okay, good.
We don't have the time.
Actually, I gave you the time. The time is 6. Because the time here, delta t, is t final minus t initial. T final here is 6 minutes minus t initial 0 minutes. So it's equal to 6. So what I'm saying here, technically, well, if you want, you can calculate it. You can calculate 8 meters divided by 6 minutes. Okay. And here you can calculate it. It will be 4 meters divided by 6 minutes. And then you take the ratio. When you will take the ratio, the denominator will cancel. Because here I will have 8 divided by delta t, and then I will have 4 divided by the same delta t. So you see that the delta t will go away, actually.
Okay. Thank you.
But you can do it and then, yes. So it depends on the question, actually. If I ask specifically, what is the average velocity? You have to take the ratio. What is the average speed? You have to take the, you have to take explicitly what is the delta t.
Yes, thank you.
No problem, Abdullah. Now let's go to this problem. Yes, Abdulaziz.
Here, if it's a velocity time graph, we take the area to find the displacement. Is it right?
That's correct. Yes, that's what I said before, right?
It's important to read. What kind of graph is it?
It's extremely important. And this is what I talked about here, Abdulaziz, right?
Yeah.
Here I gave you velocity time graph. Okay. And I asked you the displacement. I told you the displacement is area under the curve of a velocity time graph. Okay. Same way I said in class that change in velocity is the area under the curve of an acceleration time graph. You remember this, right?
Yeah.
Yes. V final minus V initial is equal to the area under the curve of an acceleration time graph between these two planes. Okay. So
what about the distance here in a VT graph? We take it like average.
You mean here?
Yeah. In the VT graph, not in
Look,
XT. It's easy.
What I ask you to do at home is here you have a position time graph, right?
Yeah.
So at home, I want you to plot the velocity time graph corresponding to the position time graph. And then from there, you plot also the acceleration time graph. Okay?
Okay, that's right.
So basically, you take this slope, you take this slope, you take this slope, you take this slope, and then you look for the acceleration. And you'll find that the acceleration is always 0, by the way. But anyway, that's another. Okay, now coming to your question now, let me first solve question number 2 here, and then I go to the first one on top. Look at question number 2. you have a mass of 5 kilograms, which is at rest at t equals 0. At rest means v is equal to 0, v naught. Then it starts moving along the x-axis, the variation of its acceleration versus time. Now here I give you acceleration time graph. And as you can see, the acceleration is varying as a function of time. I can ask many questions, but here's the question that I ask you is what is the velocity at t equals 7 seconds? And this comes back to your question. So you know that acceleration is derivative of velocity with respect to time. This means that change in velocity delta v is integral between t initial and t final of a dt, meaning area under the curve of acceleration time graph, of course, between t initial and t final and the x and the time axis. So in other words, I'm telling you that the change in velocity is the area under the curve of an acceleration time graph. So here I want it between t0 and t7. So here I will have v7 minus v0 is this integral here between 0 and 7 of a dt. Okay, so this is the area under the curve between 0 and 7 seconds. Okay, area under the curve, area of what? Of acceleration time curve between this and the time axis, t-axis. Meaning, so 0 is here, 7 is somewhere here. I need this area here. Okay, but you know that this area under the curve, technically, well, I can stop, my integral can stop at 6 actually, because from 6, the acceleration is 0 anyway. So the area is 0 because the acceleration is 0. Okay. So this here, it will be just area under the curve between 0 and 6 seconds. Okay. Okay. So derivative is a slope, integral is an area under the curve. And you have this x, you take the derivative, you get the velocity. Dx over dt. Oops. And then you take the derivative of velocity, you get what? Acceleration, which is dv over dt. Okay. So that means v is dx over dt. If I have x versus t, the slope is the velocity. A is dv over dt. If I have v versus t, velocity time graph, a is a slope. Now I can go the other way around. The other way around is an integral. Now that means what? If I have a versus t, basically, okay, let me just put it this way. This means dv is just a dt, okay? So now that means that if I take the integral, the change in velocity, delta v, is just an integral area under the curve of a AT curve, okay? Basically, an integral is an area under the curve, that's it. Now I can use it for delta v, but I also can use it for delta x. But delta x, I need which type of curve? Vt, velocity time graph. Delta v, I need what? Area under the curve of a acceleration time graph. Anyway, bottom line, let me get the area of this triangle. So the area of the triangle, of course, will be half this height here, which is 10 meters per second square, multiplied by the basis here, which is 6 seconds. You see the seconds and the second square will go away, so you will end up with 30 meters per second. Okay. And this is equal to V7 minus V0. Okay. But I already told you that V0 is 0. So that means that V7 is just 30. In some problems, I will change this. I will not tell you that I start from rest. I will tell you that at t equals 0, the velocity was, for instance, minus 2 meters per second. So this is V0. That means V7 will be just 30 plus V0. So, but now this V naught is not 0. This V naught is -2. Okay. Good. So this is just a reminder about the course, the lecture, okay? Graphical integral, slope. And at the end of the lecture, I gave you a summary of these relationship and these graphs. Is it clear, Abdulaziz?
Yeah, it's clear.
Okay, so I'll skip this. Or yeah, I will skip this. You can play with it. Now let me go to another very important part of this lecture is free fall and of this recitation. Okay. So let's look at this problem here. Okay, I want to solve this problem. Then I want to solve these two problems. If I do that, I'll be very happy. The rest, I can let you solve them. Okay, think about them. They are extremely important. Each problem that I have chosen has a key idea. At some point, everything repeats itself. I want you to get ready for the next quiz. I want everybody to get a full mark. And in the major exam, I want this section to be at top. You will be happy. Parents will be happy. Doctor will be happy. And inshallah, Allah will be happy. Okay, let's look at this. What do we have? So we have a particle which is released from rest at a height h. Now, I release it from rest, okay? Here. It takes 2 seconds for the particle to fall from point A and point B, and I ask you to look at the figure carefully. So here I am telling you that it takes 2 seconds for the particle. So here, I release it from rest. So initial velocity is 0. I release the object, it's falling down. Free fall. When I arrive here, there was a time TA. So of course, T0 will be here. Take T0 to be 0 at my origin. TA, I don't know. And then it keeps falling down. Of course, it's accelerating because it's falling down. Acceleration is downward because it's a free fall. Free fall acceleration is equal to -g, right? So I'm falling down, acceleration, V negative, acceleration negative, speeding up, falling faster and faster and faster. Now, TB here, I don't know it yet, but I told you that in the problem, it takes 2 seconds. So TB minus TA is equal to 2 seconds. Okay. Now, if you look at the graph, I gave you something else, which is as important as this. So here is my 0. So here is my H. And I told you that from the ground, B is at 60 meters. Okay. What does it mean? So if this is my 0 here, this here is at -h. This here will be at what? -h plus 60. Okay. Let me model the problem so you will see what I mean. This is my positive y, and I always choose my positive y to go upward, and always do this. You say that t equals 0 here. At t equals 0, I choose my origin of position as well. So why not? I will take it as my 0. So always time, position, velocity. What is velocity? 0. And then acceleration. Well, acceleration all over the motion is constant. Constant acceleration motion is a free fall. A is minus 9.8 meters per second square. Now let me take the ground here. This is a ground. It reached the ground here. At a time t that I don't know. By the way, that's question number C. How long does the particle take to reach the ground? Now, what is the YH when I reach the ground? Of course, it's -h. It's h distance below, so -h. What is the velocity? Let me call it VH. I don't know yet. And by the way, that's a question here. Last question, D. What is the velocity when it just reaches the ground? Now, here in between, I'm at point A. Let me say TA. What is TA? I don't know, but I can know it, and I will know it. What is YA? YA, as you see, I go down at -h from the origin, and I go back to +200 upward. So I did this -h plus 200. So basically YA is -h plus 200. What is VA? I don't know. By the way, that's the first question. TB. What is TB? I don't know, but I know that TB minus TA is equal to 2 seconds. Okay. YB. What is YB? Minus H plus 600, plus 60. What is VB? I don't know. I can know it. It's never asked, by the way. I have modeled my problem. I know everything. Now, what else do I know? I know the constant acceleration equations. But now here I will apply it to free fall. So my X will become a Y. Okay. My A will become a minus G. Of course, my X naught will become X. But here, remember, this constant acceleration motion, I apply them between t equals 0 and t equal t. So in reality, the t which is appearing in these constant acceleration equations is a difference of time. It's t minus 0. But 0 is 0. Students don't realize. Now I will write it between any 2 points, any 2 times TA and TB. And I will ask you to write these equations that I'm about to write now. With TB bigger than TA. Between any 2 points, I can say that VB, which is V at time B, is equal to VA, okay, plus A TB minus TA. Of course, A here is minus G, right? So this is the first equation. Write down this equation here. V at time B is equal to V at time A plus A, the difference of times. Number 2, VB square is equal to VA square plus 2A YB minus YA. And finally, YB is equal to, or YB is equal to YA plus VA TB minus TA plus half acceleration TB minus TA square. Okay. So now what I will do is, of course, I will use these equations, but for a free fall. So in a free fall, A is equal to minus G. So here it will be, but this is what I want you to realize. Okay. I can apply it between any points at any times, given that the acceleration is constant. Okay, so here's the key information is this here, 2 seconds. So I will say that I will use this formula here. Why? Because I know TB minus TA is 2 seconds, TB minus 2A is 2 seconds. Okay, but also I know this, YB is equal to what? YB is minus H plus 60 is equal to YA, YA is minus H plus 200. You see that minus H goes away. And then I will have here VA, which is unknown, multiplied by 2, minus half. A is minus G. Okay, so minus 9.8, T square, which is 2 square. So I have H goes away. So I end up with minus 140, because this is a displacement actually between A and B, minus 140. Okay, this is equal to what? VA multiplied by 2 minus half A, minus half 9.8 multiplied by 4. Okay, it's time, but you get my point, right? Hello? Hello?
Yes, we get it.
Yes, doctor. Yes, we do.
Okay, yes, okay, good. So this is what I did here, and I get VA is minus 60. Okay, and then I do the rest. You can do the rest, please. I want you to solve these 2 problems as well. And then you keep solving, please. And here I wanted to talk about this. This is speeds, averages. There is a lot of physics to be discussed and maths here, by the way. You have different type of speeds. You have different type of average. You have what we call harmonic average. We have arithmetic average. We have geometric average. the average of your grade, that's arithmetic average. But here we are using something called geometric average. Please solve all the problems, solve them, understand them. If you have questions, I'm open, come to office hours. I cannot solve all of them, unfortunately. So thank you very much. And inshallah, have a good day. So if this is very simple to you, that's very good news, actually. That's good news. Okay. If it's not simple, no problem. Just practice, practice. Practice does not make perfect, it makes progress. And everything depends on your acceleration. Okay. I prefer to start with a negative position, but with a very positive acceleration. So I'll end up, at the right place, inshallah. Assalamu alaikum.
Thank you, Doctor. See you tomorrow, inshallah.
Inshallah. See you tomorrow. Thank you. Okay, let's start. Bismillahir Rahmanir Rahim. So we will solve recitation problem for chapter 2. Again, we have a quiz on chapter 1 and 2 next Thursday. For chapter 2, it will come from these recitation problems. I will change, of course, the numbers, right? I will change the numbers. If it's a graph, I will change the axis. But I want you to solve this recitation problem because I carefully chose them, and each problem has its own importance. At some point, they will repeat themselves, but you have to solve them and understand them, okay? Of course, I cannot solve all of them. So I will do my best. I will solve, let's say, 8 or 9 probably right now. The rest, go ahead, solve them, and you will collect your full mark in the next quiz, inshallah. So final exam will look like the recitation problem. The midterm exam will look like the recitation problem as well, okay? The quizzes as well, of course. Okay, so let's start. We will start by this problem first. You are lucky because I did not have time to solve this problem with the other section. So let's look at it. What do we have? I think, Azam, can you help us read this problem? Okay, he's not here.
Who did you choose, Doctor?
Okay, Hussein, go ahead.
Okay. A ball is released from the top of a building of height h equals 120 meters. At the same instant, another ball is thrown vertically upward from the bottom of the building with an initial velocity VO. What should the value of VO be so that the two balls meet at height h per 2?
Excellent. Thank you very much, Hussein. So you can solve a problem, a physics problem, without drawing, but always draw a problem, okay? If it's a more complex problem, we call it modeling a problem. How do you see the problem? And then you will not waste time by doing this. Okay? So here I have two balls. One is released from the top of the building. Let's say this is the top of the building. Okay, and this is a ground. Always the ground I represent it this way. So of course, the top of the building is at a height h, which is 120 meters, right? Of course, h over 2 is right here in the middle at 60. So I have two balls. So the first ball, let me call it ball A. The problem did not talk about ball A or ball B, but for me, I call it whatever I want. Let me call it ball A. So ball A is released from the top of the building. Release means I release it from rest. Okay. Okay. So the initial velocity of ball A is 0. Okay. And I release it. So the ball is going downward. Okay. At the same time, another ball, let me call it ball B. Let me put it here. Okay, let me choose a different color. Oh, So ball B is thrown up with an initial velocity V naught. Of course, V naught will be positive, because here what I will do, and I will always ask you to do that, is I will choose my y-axis, positive y is pointing up, right? So that means everything pointing downward is negative, like the acceleration. The free fall acceleration is negative, it's minus g, minus 9.8 meter per second square. Okay, good. So that means that this velocity here, because I'm throwing it upward, is positive. Good. Okay, now at the same time, I throw this ball B upward. So the question is, with an initial velocity V naught, what should be the value of V naught such that these two balls will meet in the middle, basically at height here, okay, right in the middle. So I will choose this as my y-axis. So this will be my 0. Okay. So for ball B, what is y naught B? Minus 120. Do you agree with this? So here, y naught A is the initial position of ball A is 0, because I took it as my initial point, right? So ball B at t equals 0 is at minus 120, below my origin of position. Okay, good.
And the middle is 60, right?
Will be minus 60.
Minus 60, yeah.
Excellent. Don't forget about the minus, yes. So at h/2, here in the middle here, you will have y, let's say middle, will be minus h divided by 2, which is minus 60. Okay, now it's a free fall. Okay, so I know equation for free fall. Here, of course, equation for free fall, you have 3 equations. I will not write them down, but you know that they are in your formula sheet. You know that V at any time, okay, is equal to V naught minus GT. That's the first equation. What is the second equation? V square at any time is equal to V naught square minus 2G Y at that time minus Y naught. And what is the third equation? The third equation is Y is equal to Y naught minus half GT square plus V naught T. Okay, these are in your formula sheet. Now here I will be using which one? I will be using this one, the third one, this one. So let me write the equation for A, ball A. Of course, ball A is in red, ball B is in blue here. Let me go back and take it in red because it's much better. So let me write the equation for ball A. I will have YA at any time will be equal to what? Y naught A plus V naught A T minus half G. Okay, let me just remove this here. Minus half GT square. So Y naught A, I took it as my origin, 0. V naught A is given by the problem 0 because I release it, meaning from rest. So I have Y A at any time is just minus half GT square. Let me write the same equation for B at any time. I will have Y naught B plus V naught B multiplied by T minus half G T square. Okay. Y naught B is equal to what?
Minus 120.
20. V naught B, that's, I call it in the problem V naught.
We don't know yet.
We don't know yet, but we call it V naught. Okay. the time is the same, because here I said at the same time. Actually, the time is the same for both balls. Sometimes I can play with that. I can tell you that I release this ball, and 1 second later, I throw the second ball. So the difference of time will be t minus 1. But here at the same time, I throw them, so that means the time is the same. Okay, and here I will have minus 1 divided by half gt squared. Now, of course, when I meet YA is equal to YB, when they meet, because they meet at the same time, at the same position, okay? So that means YA of t, let me write it in, YA of t, let me write it in blue here. And they will meet at half height, so basically at minus 60. So I have to say that YA of t is equal to minus 60. Now from this equation, I can get that at which time they met. It will be just
Doctor,
2 multiplied by 60 divided by 9.8. So I will get the time of meeting. The time of meeting will be time is equal to 3.5 seconds roughly. Now, once I get the time of meeting, I plug it here into the second equation. So into the second equation, I will say that at the time of meeting, YB, which is equal to minus 60, will be equal to minus 120 plus V naught multiplied by that time, which is 3.5, minus 1/2 of G, which is 9.8, multiplied by T squared, which is 3.5 squared. So here's my only unknown is V naught, and I solve it, I get V naught. What is V naught? 34.2 or 0.3 meters per second. But you see the problem, I give you everything in 1 or 2 significant figures. So let's say just 34 meters per second.
Doctor.
Yes.
The both balls have different initial velocities, right?
That's correct.
So why do they have the same time?
Okay, good. So let's look at the velocity first. V naught A is 0. I release it. I did not throw it down. If I throw it down, it will go down here and you will have V naught A, which is negative. Okay, and you can solve that problem, by the way. I can give you the same problem, but I will not tell you that it's released from rest. I will say that a ball is thrown downward with this speed. This speed meaning the velocity will be minus because I throw it downward. Okay, now, as you said, V naught B is equal to V naught, and it's positive because it's upward. Of course, the velocity is different, but here, the key word about the time is I said at the same time. Okay, so when
yes, but the problem I don't understand why they will meet. For example, the ball A will reach that point, the middle distance, after 1 second, and the second will also reach.
So be careful. Yeah, Sheikh. Yes, your question is very good. What's your name?
Muhammad Farhan.
Muhammad, this is a good question. But be careful, because myself, when I was giving you this problem, I'm aware of that. So here, what I'm telling you is this. Is basically, when they meet, both of them are here. Do you agree with me? Ball A is here and ball B. Ball A is moving downward and ball B is moving upward. Okay? Now here, this is why I ask you, what should be the value of V naught so that the two balls meet at H divided by 2? Okay. So this is why I said, when they meet, Y of A at that time, at the meeting time, is equal to the Y of B at the meeting time. And it should be minus 60. Okay? Because that's what I want. But you can do the experiment. You throw a ball, let's say if you choose a velocity which is different from this, they will not meet at half H. Okay? So the problem depends on what I fix and what do I play with. So here I fix what? The point of meeting. And I want the initial velocity for B. But I can reformulate the same question. How I will reformulate it? I will give you the initial velocity for B, initial velocity for A, okay? It's a free fall for both of them, and I ask you where they will meet and at what time. But here, the problem is I said they will meet here. So you have to find me the initial velocity of B that will fulfill that condition. Is it clear now?
Yeah.
Yes. So this is a matter of perspective. And this is good because as your instructor, when I will give you a problem, I will be changing things. Okay. So that's why your question is very important because you go deep into these things. Okay. Now, your question could have been, what happens if I don't do it at the same time? So basically, I release A at t equals 0, but I release B 1 second after I release A. Okay. And there is a problem related to this downward, but I will not solve it here. Okay. So sometimes we don't leave at the same time. You leave 1 hour after me. Okay. So basically, my origin of time is different from your origin of time, but there is a relationship between our times. If I leave after you, my time will be your time, you know, plus 2 seconds, plus 1 second, but that's, we will see it later. But there is a problem related to that down, okay? So here what I did is I just write the equation for A, and I say that YA should be equal to minus 60. I get the time, the relevant time. And at the same time, I should say that YB is equal to minus 60 also, and the only unknown is V naught. Good. I did not have time to solve this in the previous section. So lucky you guys. No, I will not ask this in the quiz, of course. Already solved it. Okay, now let's go to the second problem. Here I have 2 cars which are 150 kilometers apart. Okay. Always draw. In physics, I can solve this problem without drawing anything. Okay. But we are in physics. You model the problem. Okay. You take your time and you put the axis properly. So let's say now they are at 150 kilometers from one another. So let's say X in kilometers. Let me call them car A and car B. So if car A is at 0, X naught A, car B will be at X naught B, which is plus 150. Okay, one car is moving at constant speed, of course. I did not say it, but you guess it, because I just said that it's moving at 60 kilometers per hour. So I'm giving you the velocity. It's moving forward in the positive direction. So VA is constant, is equal to plus 60 kilometers per hour. I will leave it in kilometers per hour, so the time will be in hours, the distance will be in kilometers. Now B, on the other hand, is moving, okay? Since they are traveling toward each other, well, this guy is moving like this, so VB will be equal to minus 40. Now the question is, in how many hours will they meet? Of course, they start moving at the same time. Okay, that's what I mean in the problem. If they don't start meeting at the same time, of course, they will meet at a different position. Okay, so let's assume that they will meet somewhere here. When they meet, well, X of A at T will be equal to X of B at that same time. Whenever you meet, and I can do the same problem, but instead of going toward each other, B can go this way. Since he's going slower, this guy will catch it anyway at some point, and I will ask you where they will meet. Okay. Anyway, where they will meet, you know that they will be at the same position at that time. Now let me write the equation for A. It's a constant acceleration motion, by the way, because in both of them, we are moving at constant speed. So A is equal to 0. Constant speed means acceleration is equal to 0. So my same equation are working, but I will use acceleration is equal to 0. So I will have what? X of A at any time, again,
X naught.
X naught plus
V naught T.
A T plus 1/2 of AT squared. But of course, A is 0. So this I can forget about it. So XA of T will be just X naught, which is 0, plus 6T multiplied by T. Now for B, I do the same. It will be X naught B. Don't forget, X naught B is equal to what? 100?
150.
50. And don't forget about this minus, because if you forget the minus, I will minus your grade. Well, I'm a nice gentleman, so I will not minus it, but well, I will minus something anyway. So minus 40 T. So that's it. Now, all what I need to do is I say that when they meet, both of them are equal. So 60T is equal to 150T minus, 150, sorry, minus 40T. So basically T is equal to 150 divided by 100. And you get it in hours if it will be this, okay? So again, when you solve a problem, try to ask yourself, what if, what if, what if? Those who do that, they will improve their physical, let's say, intuition. And they will not need to solve 100 problems from, I don't know, Dafrazo or where anyway, because in one problem, they can ask 10 questions. What if I change this? What will change? Da, 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 okay? And this is very good. Okay, is it clear? Now I can start ask the same problem, but now instead of moving at constant speed, I will say they are moving at constant acceleration. Let's say A is equal to, let's say 2 kilometers per hour squared for A. And for B, I will tell you it will be moving at, let's say, minus, okay? Or yes, minus 2, let's say minus 3 kilometers per hour squared. Where they will meet, okay? They will meet here. Now, if I ask you, this is when they will meet, at which time? Now, of course, since I got the time, I just plug it here in either this guy or the other guy, and I will find where they will meet. Okay. So now let me go to this problem. Is it clear, everyone?
Yes, it's clear.
Good.
Yeah,
now, good. If it's, you know, I'm sure you did this probably before. And by the way, this we used to solve this a long time ago. Okay. Like when two cars will meet, etc. Okay. Of course, you are not using velocity, these terms. Yeah, I just do it using our tools of Physics 101. Okay, now let me go to the next problem here. I have this figure, which is showing a velocity time graph. So I have velocity, time. So the particle starts from the origin and it's moving in a straight line, one-dimensional motion. So the question is, at what time is a particle going to change direction? And explain why. So what do you think? When, at which time precisely the particle will change direction? Anyone?
25 seconds.
25 seconds, yes. Okay. Now, while you are long process, yes. Hussein, it's a long process, yes, because I'm taking, you know, I'm explaining to everyone. Let me share. No, this is in the waiting room, not in the waiting room, in the meeting. So please, yes, please mark yourself present. Okay. I open the attendance, so mark yourself present. So what's the name of Nahar? Yes, so the form is open, you can mark yourself present. And please stay with me unless your name is Nahar, meaning you came before, right? Great. Is it opened, the form?
Yeah, it's open.
No,
Good.
that's all.
I have it in myself.
check again. I opened it already. Okay, so here I have a velocity time graph. So the question is, at what time is a particle going to change direction, and explain why? So somebody rightfully said that it will change direction at t equal 25 seconds. Why? I always thought the velocity, the sign of the velocity is giving you the direction of motion. So what is happening here? I start from rest, t equal to 0 at t equals 0. I start speeding up, okay? And you see the velocity is positive because I'm moving in the positive direction. I speed up. And when I arrive here at t equal 5 seconds, now I keep constant velocity, constant speed. Okay? So I'm still moving in the positive direction, but I put my cruise control, I'm going at constant speed. Now at t equal 20 seconds, my velocity is still on, above the time axis, it's still positive, but I'm slowing down. Why? Because this slope here is my acceleration. So the velocity is positive, but the acceleration in this here is negative. So I'm slowing down. And when I arrive at t equal 25 seconds, I stop because my velocity is 0. And then the velocity starts becoming negative, meaning I'm moving in the negative direction in this part here. Okay? So in between 25 and 30, I'm moving in the negative direction. So at 25 exactly, I'm changing the direction of motion. Second question, what is the average acceleration of the particle in the time interval t is equal to 20 seconds and 30 seconds? So you know what is average acceleration. You look at your formula sheet. By the way, you have to print out your formula sheet. So average acceleration is equal to what? Is equal to change in velocity divided by time interval. So that means v final minus v initial. So here v final will be v at t equal 30 seconds minus v initial, which is v at t equal 25 seconds or 20 seconds divided by 30 minus 20. Now, what is the velocity at 30 seconds? You have to read it from here. You read it in the graph, you see that it's equal to, of course, minus 5 minus what is the velocity at 20 seconds? You see it here.
10.
10.
10.
And you divide, and you get minus 1.5. Okay. And here, in this portion here, I have constant acceleration, by the way. So that means that my instantaneous acceleration is equal to my average acceleration. Because anyway, it's constant. Okay. A naught. But I'm talking between, of course, 20 and 30, right? When I'm here, what is my acceleration here? Between 5 and 20? 0. Because it's a slope. Okay, I will come back to this just in a second. Because acceleration is the derivative of velocity with respect to time.
Doctor,
Yes.
always when the velocity is a straight line, the acceleration will be a constant. But when it's a curve, then the acceleration will be changing.
Good. Now, what do you call straight line? Straight line is a straight line, right?
Yeah,
It
like
can
this,
be.
slope.
It can be linear. It can be constant. Okay.
Yeah.
So look at the slope. The slope of this line is constant, as you said. The slope of this line is constant, and the slope of this line is constant. So this slope is 0. That's why the velocity is constant. This slope is positive. That's why it's increasing. Slope is negative. Yes. But if the velocity is like this, like a curve, of course, this is not a constant acceleration. And I'll come back to this just in a second. That's a good question. Okay, now let's look at this problem now, which is roughly the same, but you notice I have changed just the axis. So here I start from 0 and I go to 20. Here I call it 23, and here I call it 25. It's arbitrary unit. It does not respect the scale. But this is what we do, okay? Because basically, I don't want to ask you the same question which is in the recitation or in the old exam. I will change the numbers. Okay? Those who remember the numbers, they will get it wrong. Those who understand, well, mashallah. Now, what's the question here? The question is, what is the displacement of the particle in time interval 5 seconds to time interval 25 seconds?
Minus 10.
No. So always look at what do you have? What is my graph? Here it's a velocity time graph.
Okay.
Area under the curve.
Integration.
Excellent. Area under the curve. Integration. Okay. Velocity is derivative of position with respect to time. That means dx is just what? V dt. If you integrate, you get change in position, which is displacement, is an integral of V dt. That means if I have a velocity time graph, the area under the curve will give me a displacement. So here I care about which area under the curve between 5, of course, and 25, right? So I care about this area here. So this area is positive. This area also is positive, but this area is negative. So be careful. Okay. If it's top on top, above it's positive, below it's negative. So you know how to get the area of a triangle, of a rectangle. So that's it. So we use that area under the curve. Which curve? V t. Between t initial, which is 5, and t final, which is 25, and of course the time axis. Okay, so this is the time axis. So the area of the rectangle is 150. The area of the second triangle is positive, and it's this 15. The area of the third triangle is negative, is this, and you get your displacement. So between 5 and 25, I cover a displacement of plus 160 meters. Average velocity, I already talked about it, so I will just skip it.
Doctor?
Yes.
If we have a displacement, we are going to calculate the area.
So if I have a velocity time graph,
okay,
the area under the curve of a velocity time graph will give me a displacement.
Okay.
And there is a good reminder in the last slide, in Al-Jalal slide, okay, if what I presented in class. So, okay, basically, this is a rule. A derivative graphically is a slope, okay? But an area, an integral is an area under the curve, okay? And I will remind this just in a second. Let me remind it here, maybe. You see, I start from x. I take the derivative of x with respect to time. This gives me velocity. And this is a slope. Slope of what? A position time graph. If I have a position time graph, the velocity is a slope. Now, if I take the derivative of this, I will get acceleration, which is the derivative of velocity with respect to time. Now, if I go to acceleration to here, this will give me change in velocity. From velocity to this will give me change in position. But I will come back to this. I have a couple of problems here, and I will come to them just in a second. I have a couple of problems down here. Yes. Okay. Yes, somebody has another question.
Yes. Can you, Doctor, in the quiz or exam, you may interchange the axes. You put velocity in the time, in the x-axis, and the time in the y-axis.
Okay, that's a good question. Those who did the lab right now, those who already did the lab, know that there is what we call independent variable and dependent variable. So always here, for instance, in the y-axis, I will put the dependent variable. I will put v of t. And here I will put the time. Why? Because, you know, it's like if I have x, what is y of x? Okay, what is f of x? Okay. So this x here, the horizontal axis, will be my independent variable. When I say independent variable, it's a variable which is easily accessible and controllable. Okay. And on the y-axis, in general, I will put the variable that depends on that independent variable. Okay. Mathematically, of course, I can put this on the, because you always, it's a kind of, you know, it's a relationship, right? If you can write t as function of v, but also you can write v as function of t. But v as function of t is more, let's say, useful. But mathematically, I can write a function and I will say time as a function of v. But this is not natural, let's say. It's for me, it's easier to write v as a function of time, because time is something that I can control and then I can study the velocity. Okay. So always, in general, you will see position time graph, velocity time graph, acceleration time graph, and time being always in the x-axis. A good question is this, a good example is this. What time is it? Ooh, 34, okay, I have to. So here I have typically a position, x as a function of time, which is 50 t squared minus 10 t cubed. X is in meter and t is in second. So I can ask you, for instance, what is the unit of 50? So 50 should be a length divided by t squared. So 50 is an acceleration actually. This minus 10 here, or this 10, will be a length divided by t cubed. Okay, so it's what we call a jounce or a jerk. Okay, dimensional analysis. But that's not my purpose here. The purpose is what is the average velocity of the particle between t equals 0 and t equals 3. So you write the formula. What is average velocity? Average velocity is displacement divided by delta t. So here it will be x at 3 minus x at 0 divided by 3 minus 0. So now I just replace here time by 3 seconds. I get my x of 3. At 0 second, I will get 0. And then I get my average velocity. So it's plus 60. Okay. And this average velocity is in your formula sheet. Second question, I will ask you, what is the acceleration at t equal 2 seconds? So this is an instantaneous acceleration, average between 2 points. Okay, time 1 and instantaneous, I have it. So instantaneous, I have it at t equal 2 seconds. Okay. So what is the instantaneous acceleration? Well, you know that this is a velocity. Now let me take the derivative. This is a position. So the velocity is just derivative of position as a function of time. So you know how to derive a polynomial function. So it will be plus 2 times 50, 100 t minus 30 t squared. Now from this, I get the acceleration, meaning I derive now the velocity as a function of time. So you get 100 minus 60 t. Okay. So this is the first derivative, velocity. This is the second derivative, acceleration. Now at t equal 2 seconds, I just substitute time by 2 seconds and I get my acceleration, which is minus 20. Now, since I get the acceleration of minus 20, I will ask you, is the particle accelerating or decelerating at t equal 2 seconds, and why? Is the particle accelerating or decelerating? So first,
Decelerating.
The velocity at t equal 2 seconds. So I just replace here time by 2. And I believe if you do it, you get 200 minus 120. So basically, plus 80 meters per second. And you see that the velocity at t equal 2 seconds is positive, but the acceleration is negative. Velocity positive means I'm moving in the positive direction, but the acceleration is negative. So I'm slowing down, so I'm decelerating, okay? Because I'm braking actually. So there is a force, a net force opposite to the direction of motion. I'm moving forward, but the net force is opposite, so I'm slowing down. Okay, I will take attendance again because I lost 3 or 4 students again.
Okay, I have a question, Doctor.
Yes, Amar.
Since we get the acceleration negative, so it might be having another condition that the velocity may be a negative in negative direction.
Yes, it's possible, but not at 2 seconds.
Yeah. But I mean,
you notice here, you have a function of time. You can study what is the sine of v.
Okay.
You can study mathematically what is the sine of A. Now, let's say from time going to 0 to time going to infinity. Okay.
Okay.
You can study what is a sign, and you can see between which time and which time I'm accelerating or decelerating. If both of them are positive, I'm accelerating. If both of them are negative, I'm accelerating. If they have opposite signs, it will be I'm decelerating. Okay.
Yeah, yeah.
As I said in class, I said the product AV should be positive for me to accelerate. If the product AV is negative, means I am decelerating. Now this will depend at which time.
Yeah, yeah.
Okay.
Okay.
Now let's look at this problem, because one gentleman asked this question before. So here we have a velocity time graph. Always when you have this, you look at the velocity time graph. So the question is, which of these curve describes best an object with a positive increasing acceleration? What do you think?
The green one?
The green one. Thank you very much. What's your name?
Ahmed Mohammed.
Thank you, Muhammad. Yes. So the green one. Why? So the
because
positive increasing.
That's it. Okay. So I feel like all of you understand this, so I don't need to explain that. Okay.
Doctor.
Yes.
Can you back for the previous question, please?
Yes.
Can you explain C again?
Okay. C, I'm asking at time equal 2 seconds. Am I speeding up or slowing down? All what you need to do is to calculate the acceleration at t equal 2 seconds.
Yeah. And it's minus, so it's deceleration.
Not yet. Now I have to look also at the velocity.
Oh.
And the velocity is positive. So velocity positive means I'm moving in the positive direction, but acceleration negative. You see, the product is negative. So I'm slowing down, I'm decelerating. If the velocity here was negative, mean I'm moving in the negative direction and there is a force. So basically I'm accelerating in the negative direction. That means I'm even going faster and faster and faster. I'm speeding up. Okay. So let me skip this since it's
Doctor.
okay.
About Doctor.
Yes.
About the blue one, that doesn't mean that positive. Okay. We have the green and
excellent, excellent. That's a good question. So basically, most of good students, mashallah, you are all good students. You are at KFUPM for a reason. So they will hesitate between D and B, right? But yeah. I said is the acceleration here is not constant. So B will be true if the acceleration was constant and positive. If the acceleration is constant, you remember velocity is equal to V naught plus AT. So if I have a velocity time graph, you see that it's a linear function of time. And this is what is happening for B case.
If he asks about the positive increasing velocity, it will be the green and the blue.
Now let me come now. Now here, this is a velocity time graph. Now what about position? Position will be quadratic because you will have position will be x naught plus V naught t plus half a t square. Okay. But here what I said is, I did not say that it's positive and constant. I said positively increasing. That means that my acceleration, if I want to write it down as a function of time, it will not be a constant function. It will be a positive constant multiplied by t because I want it positive but increasing in time. So that means that my velocity as a function of time will be a parabola, will be a quadratic equation. Okay, if you know it, you know that this will be half a naught t square. Okay, so because this is positive, so in a quadratic equation, the second derivative is giving you what? The concavity. So this concavity should be positive here. Okay. C is not true because in C I have something like a parabola, but the concavity is downward.
Yeah.
So I will not take C at all. Okay. Good. Now, in this question here, the position will be, let's say, something to the power t to the power 3. Okay. Okay. Anyway, it's not proportional. Of course, you will have v naught t. You will have, so here it will be 1/6 of a naught t squared. But I will not ask this because, you know, you are not supposed to know integrals, but graphically you can think about it. Okay, for the rest of the time, let me go back. Today in the morning, I started with these questions. So in these questions, so I want to solve this, and this. I want to solve this because this is extremely important. What time is it? Okay. So what should I do? Okay, let me skip this maybe and go directly to this problem here. What do you think?
Yes, I agree.
So I will skip this one because here, okay, I will skip this one. Now let me look at this one. So here, what I'm asking you, I give you a position, time graph. Okay. The question is, find the ratio of average speed divided by average velocity. So you just need to know that average speed, S average, sorry, is total distance divided by total time interval. On the other hand, average velocity is in your formula sheet. Average speed is not in your formula sheet. So write it down. Average speed is total distance divided by time. Average velocity, that's in your formula sheet. Delta x divided by delta t. So in this here, it means that it will be x final is x at 6 minutes minus x initial divided by delta t. And by the way, delta t will be 6 minutes minus 0 minutes, so 6 minutes. Let me just keep it as it is. On the other hand, so let me complete it. Now, what is the displacement here? I started at 0 here. So this is my x initial. My x final is 4. So my displacement is just 4 minus 0. So basically 4. Okay, that's my displacement. Okay, I started here and I ended up here. Now, what is my path? The path is this. I started here, I went to -2, and I came back to 0 again, and then I went to 4. So the total distance is equal to what?
6.
8.
8, yes.
8.
Yes, so it will be 8 divided by.
Can you repeat, Doctor?
So look at the path, the total distance that I have covered. I went down to -2, I came back to 0, and then I go back to 4. So -2, basically I covered here, this,
and
this.
come back again, isn't it?
You see?
Because from 8 to 10 minutes, he came back.
So this is 0, this is 6 minutes. But here I stopped because here I'm saying between 0 and 6 minutes. So I stopped here at 6 minutes. Okay. So I started at 0, I did this. So my total distance is this.
Okay.
Is 8. Now when you take the ratio, it will give you 2. Okay, I wanted to solve this, but this also is area under the curve. But here I have acceleration time graph. So delta V is just integral of A dt. So acceleration of time graph, basically the area under the curve will give you a change in velocity. So you can get V7 minus V0 is equal to the area under the curve, and you will find that it will be 30. Because this is a triangle, you know how to get the area of a triangle, right? So you get it right, and that's it. Now here I said that initially I start from rest, so V0 is equal to 0. Okay, so V7 is equal to plus 30. Okay, now let me go to the important problem here in 2 minutes. Well, the solution is given anyway. Okay? Now you need to understand the solution. That's it. Again, don't just care about the final answer. Okay? Don't just enjoy the destination. You should enjoy the journey. At the end of the day, you know, I will give you problems and you need to, you know, model your problem and think about it and solve it. So here, what I did is I have a particle or a ball, I release it from rest from here. Okay? And the ball goes down and hits the ground. Now the ground is at this height here, H, capital H. And I did not give you the H. If I gave you the H, life is easy. But I did not give you the H. Now what I said here is it takes 2 seconds for my particle to move from point A to point B. So basically, if my particles start falling down here, it reached point A at TA. I don't know what is TA. It reached point B at TB. I don't know what is TB, but I know that TB minus TA is equal to 2 seconds. Okay? Now, of course, my particle started falling down from here. So I will take it as my T0. And of course, I will take it as my Y0, 0. And positive Y is going up. So what is the ground with respect? What is the position of the ground? YH. It will be at minus H, which is because it's at H below my graph. Okay, so we will stop here. Let me just talk about this in a second. Now, so from here to here, it's minus H. So what is YB? YB will be minus H, but plus 60, because I go down, H down, and then I go up 60. So it will be minus H plus 60. So YA will be equal to minus H plus 200, meaning this is my 0. I go back down minus H, and then I go up again 200. Because the problem is I did not give you directly this height here. Now, what's the question? What is the velocity of the particle at point A? So please remember this. In the problem, the equation I gave you, I take it between t equals 0 and t equals t. So students don't realize that it's delta t, t minus 0. So those who are still here, well, you will get bonus point. No, I'm joking. It's time. So let's stop here because I don't want to take your time. But let me just say this before you finish. If I want to finish, this is what I want you to remember. I can write the equation between TA and TB. So that will give me this V at TB, and of course TB is bigger than TA. V at time B is equal to V at time A minus G TB minus TA. So this is the first equation. Second equation, VB square is equal to VA square. Write down this because this is very important. If you know it, no need to write it. If you don't know it, YB minus YA. And finally, last equation is YB, okay? YB is equal to YA plus VA TB minus TA minus half G TB minus TA square. So let's stop here. So here, what do? I will use the last equation here, okay? Because I know TB minus TA, I know TB minus TA, and I know YB, Y minus YA. Actually, YB minus YA is just minus 140. So I end up with this. Basically, minus 140 will be equal to VA multiplied by 2 minus 1/2 of 9.8 multiplied by 2 squared. This will give me VA. Okay. Well, thank you very much. Well, you were patient actually, so I will remember that inshallah, and you will get all full mark.
Doctor.
So thank you.
Thank you.
Those who left will not have full mark of, will not have minus point. No problem. I'm just joking. So, but I appreciate you staying a little bit. These equations are very important because in reality, you can apply them between any 2 points. Okay?
Doctor.
Thank you very much. Yes, I'm available for questions.
The quiz will be multiple choice or?
Good. I will discuss this tomorrow in class, inshallah. Okay.
Okay.
I want to say it once in front of everyone.
Okay, thank you.
Thank you very much. And inshallah, see you tomorrow. Have a good day.
Have a good day too.
So here, I will use the third equation, right? So YB minus YA, which is equal to minus 140, is equal to VA, that I don't know, multiplied by TB minus TA, which is equal to 2 minus 1/2 of 9.8 multiplied by 2 square. So the only unknown here is VA. Okay, so if I do the calculation, I solve for VA and I will get minus 60.2, I believe, right? But in the same number of seconds, I will have, let's say, 60. Let me write it 60 because I wanted it two significant figures. I will have 60 meters per second. Okay, so let me repeat that because this is all the sync. So you model your problem. This is my y-axis. You don't need to do it, but it's good for your, let's say, when you solve a problem, try to solve it in a systematic way. Okay. So at t equals 0 here, my position of my particle is y0, and I will take it as my origin of position 0. What is the velocity? I release it from rest, so v0 is equal to 0. Now the ground is here. When I will reach the ground, I will call that time th. I don't know it yet, but I will know it. By the way, that's the question number C. How long does it take the particle to reach the ground? Okay, th. Now, what is my position? YH. H, of course, minus h, because it's at a height h below the 0. Now, what is the velocity when it hits the ground? I don't know yet. I will know it later. VH, by the way, that's the last question, D. What is the velocity of the particle just before impact with the ground? Okay, good. And in all the problem, it's a free fall problem. So the acceleration is downward and is equal to minus 9.8. Now, at time TA, what is the time? I don't know. Now, what is the position YA? YA, this is my 0. I go down here, minus h, and I go 200 up. So if I want to get YA, as you see, you go down minus h, and then you go plus 20. So YA is just plus 200 is equal to minus h plus 200. Okay. Now, what is the velocity when I reach A? I don't know. By the way, that's the first question. What is the velocity of the particle when I reach A? Now, TB. TB, I don't know. YB, I know. It's minus h plus 60. And finally, what is the velocity VB? I don't know. I can know. But it was not asked anyway. Okay. So you see, I have all these unknowns. If I want to give the same problem in a quiz, I will give you these data and I ask you the unknown. Okay. But this is a systematic way. You put the time, you put the position, and you put the velocities. So here I will apply the constant acceleration formulas or equation, but between TA and TB. So the first formula, as I said, is VB, because here TB is bigger than TA. So VB will be equal to VA minus G delta T. What do I call delta T here? Is basically TB minus TA. Okay, this is what I call delta T. Second, YB, meaning Y at time B, is equal to YA plus VA, basically delta T, which is TB minus TA, minus half G delta T square. Again, delta T is TB minus TA. And finally, the last equation is VB square, basically V at time B square is equal to VA square minus 2G, let's say delta Y, okay? Or let's say YB minus YA. So first question, I will use this because I need VA, right? So I'll say YB minus YA. By the way, YB minus YA is just minus 140. So minus 140 is equal to VA, that I don't know, multiplied by TB minus TA, which is delta T, which is 2 seconds. Okay, because here, the first line here, I said it takes 2 seconds for the particle to fall from point A to point B. So TB minus TA is equal to 2 seconds. This is the data of the problem. So VA multiplied by 2 seconds minus half G, which is 9.8, multiplied by 2 seconds square. And I solve for this. The only unknown is VA. And you get VA, which gives you minus 60 meters per second. Okay. Now the second question is calculate the height H. Now, since I get VA now, I can use that information, right? So in the first question, the difficulty was I did not give you this height, right? Yeah, that's why. But now let me use which equation I can use. I can use VA square is equal to V naught square minus 2G YA minus Y naught. Constant acceleration, I can use it between any point. I can use it between O and A. I can use it between A and B. I can use it between O and H. Okay, these three equations, I can use them between any 2 points here because anyway, I always have constant acceleration. So here, let me use it between here. So I will have VA square, which is minus 60 square, is equal to V naught square, which is 0, minus 2G, 2 multiplied by 9.8. Now, what is YA minus Y naught? YA, I know it already. YA is equal to minus H plus 200. Okay, Y naught is 0. So the only unknown is H, and you get it right. Okay, there is another way to do it. You can get the time, okay, and then you get it. But here I just use the fact that I know velocity here, V naught is 0. I know VA here, which is what? Minus 60. So I can use that information, this formula here, to get the H. Okay. When you do it, you get H is equal to 385. Okay. And please solve the rest of the problems. Okay. I will skip the rest because the solutions are given anyway. Let me erase this. Okay. So you can solve it and then you will get the same these are the same answers. There are many ways to solve this problem. I can pass by equation number 1, equation number 2, or equation number 3. Okay, I wanted to solve this problem also in class. I did not have time. Let me put it in the recording. So an object is thrown vertically upward. Okay. So model the problem. This is extremely important, always. This is my vertical axis. Let's say that I started from here. Okay, let's say it's a ball. I throw it upward with a vertical velocity. Let me change the color of the pen. So I throw it vertically upward with an initial velocity V naught. Okay, which is positive because everything pointing upward is positive. Everything pointing downward, the acceleration, by the way, is always constant. It's a free fall acceleration. At any point, the acceleration is constant. Okay, it's a free fall. But of course, the velocity is changing. Okay, so at t equals 0, this is where my object is. I throw it upward with an initial velocity V naught. So it has an upward velocity of 25 meters per second when it reaches 1/4 of its maximum height, right, from the launch point. So I throw it upward, I will reach a maximum height. Now I will reach the maximum height at a certain time. Let me call it TH, capital H, meaning maximum height. Okay, so if my launch point is my 0 of position, and of course my initial velocity is unknown. So again, always time, position, velocity, acceleration is always constant here because it's a free fall. Now here, at maximum height, what is my position? YH, let me call it capital H, plus capital H because it's upward. It's above my 0. Now, what is my velocity at maximum height? At maximum height, I stop. So the velocity at maximum height is 0. Always. I go up, 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 up. Maximum height, I stop momentarily. Okay? And then I start going down after that. Okay? Of course, at any of these points, so the object is going up, 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 up. Maximum height stops and fall down again. So at any of these points, the acceleration is still constant. Good. Now here I said that it has an upward velocity of 25 meters per second when it reaches 1/4 of its maximum height. So this is the maximum height, h. Let me cut it into 4. 1, 2, 3, 4. So let's say when I'm here at t1/4, let's say. So what is the y here? Is maximum height divided by 4. And what is the velocity? v1/4. I can call it VA, VB, whatever you want, but let me call it v1/4. It will be plus 25. But plus 25 because it's going upward, right? So here I have 3 points. I have point 0. I have point what I call 1/4, basically at 1/4 of maximum height. And then I have a point H. Okay. So I can apply my constant acceleration equations. Either I can use it between these two gentlemen, or between these two gentlemen, or between these two gentlemen. So here I'm talking about velocity. I did not talk about time. I'm just talking about velocity and position. So I will be using this formula here. V alpha square is equal to V beta square minus 2G Y alpha minus Y beta. Alpha and beta being 0, 1/4, and H. Now first, let me use it between, let's say 0 and H. Okay. So I will say VH square is equal to V naught square minus 2G YH minus Y naught. So VH square is the velocity at maximum height is 0, is equal to V naught square minus 2G YH minus Y is equal to H. Okay. So I have a first equation, 2 unknown. So I can write that H is just equal to V naught square divided by 2G. So I don't know V naught, but also I don't know H. Now let me use another piece of information to get what I need. So the other piece of information, I have to use the velocity at 1/4 because it's given in the data. So now let me apply this equation 1 here. This equation here now between, let's say 1/4 and H. So I will say what? I can say, yes, I can use that. I can say that VH square is equal to V1/4 square minus 2G YH minus Y1/4. So VH square is 0. Okay. So this will be equal to V1/4. It will be 25 squared minus 2G YH. What is YH? Of course, it's H. Minus 1/4 of H. So now I have my second equation. But this second equation here will give me H. Okay? So now once I get H, I can come here and I get my V0. Okay? Good. So please have a look at it. And this is what I did in the solution here. Okay? But I did not give details. That's why I tried to give you details. So at the final answer is 28.9 meters per second. You just apply this equation here between two carefully chosen positions. Okay. Good. Please solve the rest of the problems, enjoy, and do your best. You will not have regrets, inshallah. Thank you. Assalamu alaikum.